Today we are going to discuss linear evaluating and operations. So if you are taking notes on a separate sheet of paper, please title it linear evaluating and operations. So title it what I am highlighting in yellow, please. Today's objectives is to apply function notation and interpret function notation and evaluate functions for an input, identifying domain and range. Your language objective is to be able to explain function notation using the stem substitute blank in for blank. Okay, so the first set of problems in those notes, all of them use substitution and parentheses. So all those problems use substitution and parentheses. So first, if you could take just a second, pause the video and think about these few statements that say recall. So first, the domain is all the blank values, the range is all the blank values, and then the x-intercept is where the line crosses the blank axis, and the y-intercept is where the line crosses the blank axis. So pause the video and take a minute and try to fill in those blanks. Okay, so hopefully you paused the video. So I'm going to sketch a graph down here, a grid. So if you remember in a grid, the horizontal axis is the x-axis and the vertical axis is the y-axis. So the domain is all of the x values. So the domain goes left to right. So it's all these values along this line here. The range are the y values. So the y values go up and down. So it goes this way. So here's all the y values. You can go down, you can go up. These are all the y values. Now, if I have, so that takes care of those two. The next two, the intercepts. So where the graph touches, the x-axis, so let's say it's here, this is the x-intercept. So the x-intercept is where the graph crosses the x-axis. Then the y-intercept, let's say it's this point up here, this is where the graph crosses the y-axis. So it's the y-intercept. Just fix this y. So that's the y-intercept. Okay. So this, you guys talked about this in Algebra 1, but I just wanted to bring that to your attention because we're going to talk a lot about domain and range. Remember, domain is input and range is output. And we'll review this again in just a minute. So some examples. So this example wants you to find a y-intercept. So they give you the equation there. It says 2x plus 4y equals 12. And then they give you an ordered pair. So remember, ordered pairs are x, comma, y. So they give you the x value, and we got to find the y value. So they tell you that x is 0. So we're going to substitute 0 in for x. So we're going to rewrite our equation. Instead of putting an x, we're going to put parentheses, and then we're going to put our 0 inside the parentheses. Plus 4y equals 12. And then draw the line down the middle of the equal to sign. Whatever you do on one side of the line, you have to do to the other. So now we're just going to solve this equation. So 2 times 0, that's just 0. That goes away. There's nothing left. So I just get 4y equals 12. Next, how do we get, so this is 4 times y equals 12. So if we want to get rid of the 4, how do we undo the multiplication? Very good. We're going to divide. So divide both sides by 4. So this is y equals 3. So we're not quite done because we were given an ordered pair to start with. So we need to put our answer as an ordered pair. So we know X was 0 and Y, we found that to be 3. So your answer here is the ordered pair 0, 3. Next example, I want you to try this one. So pause the video and give this one a shot. Okay. So just remember ordered pair X, Y, which one do they give you? So you try this one on your own. Make sure to pause the video. The next one, find the X and Y intercepts. So they give you the graph is on the left and the question's on the right. So it says find the X and Y intercepts. So remember, the x-intercept is where the line crosses the x-axis. So here's my x-axis, here's my y-axis. So this graph crosses at this point. So notice their scale here, they're counting by halves. So this is a half, this is 1, this is 1.5. So our x-intercept, our x value is 1.5, and our y value, well, we didn't move up or down. We stayed right along, because remember, this is the origin, it was 0, 0, and we just moved right 1.5. We didn't move up or down. So this is going to be 1.5, 0. The y-intercept on this graph, again, if we start at the origin, we move up a half and then another half, and we're up at 1. So this is the point 0, 1. So here's your y-intercept. Here's your x-intercept. This next example, 3x minus y equals 4. So we're going to blank one in for blank. So notice they have, again, they give you guys an ordered pair x, y. They give you the x. So here we're going to substitute 1 in for x. So instead of writing x, I'm going to put parentheses. So 3 parentheses 1 minus y equals 4. Then we're just going to solve this. So draw your line down the middle of the equal to sign. 3 times 1 is 3. And I'm going to show the 1 in front of the y. So remember, y and negative. So y and 1y are the same thing. That means negative y and negative 1y are also the same thing. We don't often include the negative 1, we don't often include the 1 there, but I want to show you that it's there. Excuse me. So now I'm going to solve this for y. So first I got to get rid of the 3. So I'm going to subtract 3 from both sides. These 3's cancel out. I get negative 1y equals 1. Now, you're not done yet because we don't want this to say negative y. We want it to say positive y. So we need to divide everything by negative 1. So these negative 1's cancel. And now I have positive y equals negative 1. And that's the answer there. But remember, you were given an ordered pair. So we need to put our answer as an ordered pair. So x was 1 and y is negative 1. So 1, negative 1. Pause the video and give the next example a try. Okay, so here is the solution to that example that I asked you to try. So you were supposed to substitute 2 in for y. So you should have a 3x minus parentheses 2 equals 4. And then you should have just solved 3x minus 2 equals 4. So you would add 2 to both sides. So I got you 3x equals 6. And then divide by 3, so your answer would be x equals 2. And then your ordered pair is 2, 2. another example, negative 2x plus y equals 9. So again, this is your ordered pair x comma y. They didn't give you x, but they gave you y. So we're going to substitute 1 in for y. So this is going to be negative 2x plus parentheses 1. So I'm putting my parentheses in my 1 because I'm substituting 1 in for y, and that equals 9. Draw your line down the middle of the equal to sign, and solve that for x. So negative 2x plus 1 equals 9. Now we're just going to solve this for x. So we're going to subtract 1 from both sides. So those ones cancel. This is negative 2x equals 8. And then to get rid of the multiplying by 2, we're going to divide by 2. So you get x equals negative 4. So your ordered pair here is going to be negative 4. So x is negative 4 and y was 1. Okay, pause the video and I want you to try the one on the right. Remember, this is your ordered pair x comma y. Okay, so hopefully you paused it. So here we're substituting 1 in for x. So negative 2 parentheses 1 plus y equals 9. We're going to simplify negative 2 times 1 is negative 2. So negative 2 plus y equals 9. Add 2 to both sides. So you get y equals 11. So your ordered pair here is 1 comma 11. Okay, so these next few problems involve what we call function notation. So function notation is a little different than what we were just working with. We were working with sort of equations just now. So something like y equals 3x plus 4 is an example of an equation, okay? But we often use, instead of saying y equals 3x plus 4, we often use what's called function notation. And you'll see it often written like this. F of x equals 3x plus 4. So what this notation does is it really is nice when you're graphing multiple functions on the same graph. You can identify them easily. But also it shows you your input, which is the x, and then your output, which would be on the left. Okay. So it shows your function in this nice notation. As I said, the most popular notation is the f of x notation, and we read it f of x. It's important to know that this is not saying f times x. So this is not multiplying. This is just saying f of x. So this means where the x is your input value. So I already sort of mentioned this, that the x value is your input, and then on the other side is your output. Guys, we call the output your y value. Okay, so if you look at the grid below, remember in the coordinate plane you start at the point 0, 0. Your inputs are everything along this line. So you put any of these things into your function, and then it will give you an output. So it will give you something along this line right here. So it'll give you something along the y-axis. So the y's are always the output. So I like to think of, when I think of functions, I like to think of, you can think of it as like a vending machine or a gumball machine. If you've used either one of those ever, you kind of already know what a function is if you've ever used one of those. So remember, like in a vending machine, you put your money into the machine. So you put your money in. Okay, this is your input. So you put your money into the machine. You type in the buttons for the food that you want out of the machine, and then the machine spits out the food, right? The gumball machine works the same way. You put your money in, you twist that little dial, and then out comes your gumball. Now, typically in both of these machines, you only get one thing out. Like if you put $1 in a vending machine, you should only be getting out like one bag of chips, right? Or one thing of pop or whatever you're getting from the vending machine. So that's very similar to how functions work. So for functions, each input has exactly one output. And then I sort of drew a little machine here. I have a machine here for you right here. So here's your X is your input. Your function is whatever your function is. So in this case, it's 3x plus 1. So you put in x to your function, and then f of x will be your output. So you'll get an output after you put in your input. So this is your y. So each input, so each x value has exactly one y value or output. So let's see an example where we use function notation. So f of x equals 4x minus 7, and they want you to find f of 3. Well, here's x. Remember, x is the input, and I'm given an x value, so I'm given 3. So I'm given my input. So I'm going to substitute 3 in for x. So what this would look like is this. I'm going to write down my function. F of x equals 4x minus 7. Remember, this side is your input. This is going to give you a y value. So what we're going to do is we're going to substitute 3 in for x. So everywhere that I see x, I'm going to put a 3. So f of 3 equals, and now on the right side, this is going to be 4 parentheses. So I'm substituting 3 in for x minus 7. You don't have to draw a line here, but you can. The left side is never going to change. F of 3, it's going to stay the same. This is just saying when my input is 3, here's what my output will be. So this side won't change, but the left side will. The left side is like the left side is a math problem. Like you could plug that into your calculator and get a result. But you can't plug in this into you couldn't plug this into your calculator. Your calculator wouldn't understand what that means. So 4 times 3 gets you 12 minus 7. So that means f of 3 is 5. Now, we're not quite done. I want us to stay consistent here with what we were doing earlier. This is my x value. This is my input. That means this is my output. This is my y value. So I write my answer as an ordered pair, 3, 5. I want you to pause the video. And I want you to try the example to the right. Okay, so hopefully you did pause it and you attempted this one on your own. So your input was 4, so I'm substituting 4 in for x. And then your output we didn't know, that was the question mark. So we have f of x equals 4x minus 7. So we substitute 4 in. So f of 4 equals 4 times 4 minus 7. That means f of 4 equals 16 minus 7. So f of 4 equals 9. And then make sure to write your answer as an ordered pair. So the input, your x value was 4 and your y value is 9. So the ordered pair is 4, 9 for that one. Okay, another example. So f of x equals negative 3x plus 5. So again, notice here's my input. This time I'm still given an input value. I don't know my output. Whoops. So I don't know the output. So instead of writing output, I'm just going to say y, just because I don't have enough space. I guess here I'll write, here I'll write x. Okay, so we're substituting here -2 in for x. So we're plugging in for my input. So this will say f of x equals -3x plus 5. You can go ahead and draw the line. So I'm putting my input as -2. So I'm putting parentheses -2 plus 5. So -3 parentheses -2 plus 5. So f of -2, -3 times -2 is 6 plus 5. So that means f of -2 is 11. So remember, you're not done there. This is your x. This is your y. So you got to write your ordered pair -2, 11. Okay. Pause the video. Do this next practice. I'm not going to display the answer for this next practice one. We'll go over the answer to this one in the live session. Okay. So give this one a try, and we'll go over the answer to this in our live meet. So make sure you pause the video and give that one a try. Okay, this next example is very important. It's very different. It's a little bit different than what we just were doing. So notice, here's my input is x. My input didn't change. So I'm not going to change the x value. But what changed is this. I'm changing my output, which is the y. So we are going to substitute 22. We're not substituting it in for x because it's not in the x spot. We're given x there. So we're going to substitute 22 in for y. But there's no, but we don't see y in the equation up here. And I'll show you where we're going to plug this in. So f of x equals -5x plus 7. So the 22 is our output, okay? So that means instead of writing f of x, I'm going to write 22 equals -5x plus 7 because 22 is not an input, so we can't put it in for x. So our only other option is to put it in for f of x. So instead of writing f of x there, we're going to write 22 there. So really, I could have said substitute 22 in for f of x if I really wanted to say that, but you could write y there. So we're going to solve this. We're going to subtract 7. So let's get you 15 equals -5x. Divide both sides by -5. So this is -3 equals x. So my answer is the ordered pair x is -3. And my y value, we said, was 22. So this is going to be 22. Okay, this one's a little trickier, but I'm confident that you guys can do it. So go ahead, and the one on the right is practice. So remember, this is your input. Oops, just like the one I just did. Your input is x. It didn't change, but you have the output. You have your y value, or you could think of it as f of x. So you have your f of x value. So you're going to substitute 12 in for f of x. Go ahead and try that. Hit pause. Try it on your own. And when you hit play, you'll see the answer there. So go ahead and pause the video. Okay, so for that one, you were plugging in 12 for f of x. So f of x equals -5x plus 7. 12 equals -5x plus 7. So just remember, you did not get an input value, so you could not be plugging in for x. It had to change. You had to put it in for f of x. So subtract 7 from both sides. So that gets you 5 equals -5x. divide both sides by -5, and you get -1 equals x. So your answer, remember, has to be the ordered pair -1, 12. Okay. So one more example. So f of x equals x divided by 8 minus 2. So here we're substituting, just like before, this is my f of x value, or if you want to still think of it, that's your y value. So I'm substituting 2 in for f of x. So I'm going to write f of x equals x divided by 8 minus 2. Draw the line, and I'm substituting 2 in for f of x. Sorry, this looks messy. Let me clean that up. But I'm substituting 2 in for f of x. I'm going to say 2 equals x divided by 8 minus 2. Now we're just going to solve this equation. So we'll add 2 to both sides. So that gets me 4 equals x divided by 8. So we have to undo division by 8 by multiplying both sides by 8. Okay, so if we, 8 times 4 is 32. So 32 is my x value, and my y value, this is 32, comma, and the y value we said was 2. So 32, comma 2. Pause the video and do the next problem. This one we will go over in our live meet. So this problem we'll go over in our live meet if you have questions on it. So give it a try. So this is going to work very similarly to how the previous one that I just did worked. Okay, it'll be very similar. All right. So hopefully you paused it. So let's do a little bit of review, and then I'll give you some problems to try. So each problem that we worked with today, here's a word wall for you, by the way, is substitution So we use substitution all throughout today's lesson. We needed to use parentheses when we substituted our value in. Our solutions are written as a coordinate pair. So this is where we had the x comma y. So that's how we write our solutions. All right, so your homework, it's section 2.3 from a book. I posted this PDF of this page on the Google Classroom. The problems are 43 to 49 odds. So that's 43, 45, 47, 49. Those 4 problems, they're all evaluating. And if you need help with those, just send me a message through Google Classroom, through Remind, or email me. Any one of those methods would be perfect. So go ahead and try those. Good luck.